we all coordinate that. So
Exactly, all in one shot.
You know, I could be more impressed with the fact that we did it than I'm mad that we did it.
Yeah,
Coordinate everything.
exactly. All right, so I did not. We finished the disc or washer method, depending on how you want to think about it. Same concept on last Thursday, but I didn't go into the other method that we can use to find volume, which is known as the cylinder method. So, first thing I want to do though is let's try to do this problem with what you currently know. Equation is y equals 2x squared minus x to the third.
really,
There we go. And we're rotating around the y-axis. Yes, but it's being bound by that. It's not rotating around that. Because this equation, if you look at it quickly, it ends up doing something like that, and it will go down below it. So you're bounding it there. That's what it is. Actually, it goes like that. All right. So for our disk method, what's the process that we have to do?
Pi r squared. We got to find our r.
Okay. So we need a pi r squared. Yes.
Find the section between the two.
Yeah. So we're going to need our intersection points on this one.
Our inner and outer.
So we need our R, we need our intersection. Horrible speller, don't worry, that's why I teach math. Yeah, I was gonna say, you know what it says, so that's all that really truly matters. And I typically know when I spell something wrong, it's just like, I just don't feel like going back and fixing it. All right, what else?
Y or x axis.
We're rotating around the y-axis. It says that in the problem. So then we need it in terms of what? Huh?
like the left and right.
Okay, but what do I need my equation in terms of to rotate around the y-axis?
I'm just guessing.
I need x equals, so I have to have it, if the y is, it's in terms of y, so it's got to be x equals. Right now, my equation is y equals.
Changed it.
Oh, so my brain was right, but I said it wrong.
Yeah.
Okay.
So you're right. So I have y equals, I need to get it to x equals. Can you do that?
For this problem, probably
Yes.
not.
I think you could do it for first equation, but I don't know how to do it for y.
Okay. Do it for the first equation.
If you set it equal to 0, just like all the x's on one side.
Well, all the x's are on one side right now.
We get like
I need to make it so that I have x equals. And a bunch of y's over here.
I don't say we can't. Personally.
Yeah, I feel like this is a trick question.
Yeah, because you wouldn't give us this exact equation if we couldn't.
All right, so let's look at the graph. So there's my graph. Okay. Gotten good at Desmos, I can make it look exactly like I want to. All right, so if for some reason you could solve it for y, which would be quite difficult. If we're rotating it around this axis here, right? My radius, it's the same equation on my inner and my outer. So we run into a problem of this problem should be able to be done. We don't have the method to do it yet. the method that we currently have doesn't work very well for this problem. Okay, because we can't solve that for y, because I have two x's. Like even if I factored it out, because I could pull out the x squared and get 2 minus x there. So it's like I could get that. Being able to try to solve it because there's multiple x's for the y's just isn't going to work very well. So, and even if I did, I still would end up having my radius be one equation instead of two equations where I'm looking at the intersection. So we need a new method. This method is known as the cylinder method. So the cylinder method looks at it in terms of a infinitely thin cylinder. So I like to visualize it as the label on a soup can. Okay, not the can, the label on it. Okay, because if you think about a label, it's infinitely thin. So if you were looking at it, you're in essence looking at the surface area of that label. Okay, so that's in essence what we're looking at. So when we're looking at the equation, so we're still looking for volume. If you took that label and pulled it off, the length there would be my what of the circle. So this length here is right. Yes. So that right there, that's my circumference. And the circumference of a circle is 2 pi r, right? Okay. So in this situation that we're looking at right now, the r is going to be my x. So that's why we have my circumference as 2 pi x. If we're rotating around the y-axis, it's going to be in terms of x's. That's how we're going to be able to do this problem. So my x is going to be my radius, because we're looking at how far out from the y-axis we're going till we hit the actual function. Okay, does that part make sense? Okay. The height, so if we're looking for volume, it's the circumference. So basically surface area is the circumference times the height, right? That's how you find surface area. So my height is my f of x, because that's coming from the x-axis up to the equation. So that's going to come up and hit whatever my function is. So that's why the height is my f of x. And the thickness, the point of an integral is to get that to be infinitely thin. So my thickness is my dx. So you're not actually calculating that. That's actually just the dx. Yes.
So the delta x is how thin that slice is.
Yes, how thin that cylinder is. And the cylinder is basically gets infinitely thin using the integral.
So in previous method, when we set the integral from a to b, like in this instance, a to b would be like that'd be delta x.
Yeah, we're still going to be looking at that part. Yeah. So here I can show you I can give you a nice old visual of it. So this ends up being like so we have our one cylinder, and then we're looking at those slices, and we're looking at it from wherever we're starting, the A to the B, so on the x-axis. And the more cylinders I have, the thinner it gets. Yeah, it's Riemann sums. Yes, that's what we're doing. So Riemann sums basically does it. An integral is basically an infinite Riemann sum. It basically is taking it and crushing that length, that thickness, or whatever I'm looking at, all the way down to it infinitely thin. That's what we're doing with the integral.
So like for Riemann sums, you get the area under the curve, and now we just multiply it by
Yeah.
100.
Yes. Yep. So, all right. So that's basically the two pieces of information we're going to need is very similar to what we did before. We're going to need our radius and we're going to need our function. So on the other one, we just needed our radius and we were able to plug that in. This one, we're going to need our height as well, which is my function situation. All right, so now let's look at that problem that we looked at a minute ago, but using this method. So here's my function and the graph of it. So now we're not looking, in essence, this way for my radius or for the functions. We're looking up. So we're only going to hit the function once. So that makes my life a lot easier in that situation. If you were to actually take that problem and solve for 0, so we had the 2x squared and then the x minus 2, or sorry, x squared and then 2 minus x. So x equals 0 and x equals 2 are my endpoints where it intersects the y equals 0 line or the y-axis or the x-axis. And so those are my two intersection points there. So my integral is going to go from 0 to 2. Now, my radius of the cylinder is my x-axis, because we basically are looking at how we're going to get back to the y-axis, because that's what we're rotating it around. So wherever I am, going back to the y-axis would be how far I am, would be my x. So my circumference is 2 pi x, because r in this situation equals x. Because that's from the center, my axis of rotation, to my cylinder that I'm looking at whatever point, because it's going to change as I go, is x.
Okay, so we're just putting in x.
Yeah. And it's not always going to be x. That can actually change. We're going to look at some problems where that does change. But for the most part, it's going to be from the axis to wherever I'm going. And then the other piece of information I need is my height. So we're looking at it from the x-axis up to the function. So in this case, my height is 2x squared minus x to the third. So we're going to multiply this by 2x squared minus x to the third. And then my thickness is dx. Yes.
I feel like I already asked this again.
That's okay.
So I understand that if you're writing out like an integral in terms of x, it's like you put dx.
Yep.
But when you said that the dx is thickness, oh, yeah, no, I asked this already.
That's okay. It's okay. Yeah, and you're going to hear me say that this is the last time I'm going to say it, because in all honesty, it doesn't make any difference. If we're doing it in terms of x, you're going to put the x at the end. If we're doing it in terms of y, you're going to put dy at the end. It stands for thickness, but you don't need to worry about that piece. The only two things you really truly need to worry about is the radius and the height for this method. Those are the two pieces of information you need to worry about to plug into the formula. The rest of the stuff basically stays the same. It's always going to be 2 pi, and it's always going to be a dx at the end. All right. So we've got our integral now. Now we just got to solve it. We can pull out the 2 pi, and then we can distribute this piece so we don't have the multiplication. So we're going to pull out the 2 pi, integral from 0 to 2 of 2x to the third minus x to the fourth dx. All right, find me my integral and find me my answer. I'm gonna go back there a second.
Right. Okay.
Oh, sorry. Yeah,
Just wanted to.
I just needed to make it a little smaller.
Wanted to make sure it wasn't feeling basic now. Where can't do it.
Okay.
No, don't do that yet. Do those. Add one to the end. Yep, you add one to the end. That's the river. That's fine, that's why I was, that's. So add one to the end. And then you put it underneath. Before. That'd be that. Oh, that's not. Ill. Two and 32. Which is going to be 16 by 9. Oh, yes. Yeah. Yeah. Yep. I like this one. Oh, yeah. Won't go late in the rates. Imagine if we knew how to do this, we would do it really good with cones. Find the surface area of a cone.
All right, so your integral should have been 2 pi 1/2 x to the 4th minus 1/5 x to the 5th. Plugging in the 0 and the 2. You get 2 pi times 8 minus 32 over 5, which comes out to be 16 over 5 pi. And that's how I'd want to see the answer written. You can do whichever way you want to do it. It doesn't make any difference. That. Oh, no. So that's where you pull out the 2 pi and don't worry about that till the end. So. Yeah, don't worry about the 2 pi until after you do the deal with the fractions.
Yeah, probably do the math first too.
All right. So both methods will technically work for every single problem. Sometimes one method is a lot easier than the others, and sometimes based on trying to actually simplify the equation down, you just can't. So you'd have to be forced to use one method over the other one. So try. I'll do this one first. All right, so we have y equals the square root of x, and we're doing it from 0 to 1 on the y-axis, and we're rotating around the x-axis.
Will all the problems on the tests be ordered like these?
Yeah.
Okay.
The majority of your test is going to be chapter 7. There'll be a few questions from this on there. The majority of the test will be chapter 7.
Chapter 7.
Is the stuff that we're covering starting Thursday.
Is it a mean one?
Chapter 7 is probably, most people consider chapter 7 the hardest chapter.
Well.
So. All right. So if we're going to do this in terms of the cylinder method, I need a few pieces of information. First thing is, if we're rotating around the x-axis, I need it in terms of y. So I need x equals, not y equals. So to change that, we would square both sides. So x ends up equaling y squared. Okay. And we also need to look at it in terms of the x, or actually, never mind. We have the y there for that one. So that's 0 to 1. We're good with that part. All right. So when I'm looking at this, we need to come up with my radius and my height. So my radius is, since we're rotating around the x-axis, my radius is y, because we're going up in this situation.
But if it was on a y-axis, it would be x.
Yes, but then I wouldn't have solved for x on that side. It'd have been, I would have kept the y equals this cubed root of x, yes.
Oh, but it-
No. So, and I can't remember your name. What was it? I'm going to totally chop it. All right. So he came up earlier and was asking me, like, we were looking at how to figure out radius when it was shifted over to like x equals 2 instead of the y-axis. And what I was telling him was, you're always looking at rotating, you're always looking at going back to the axis. So when you're doing your integral, it's always going back to the axis to calculate that. Okay. So this one actually is that part entirely. And this is very important in terms of that. Because if we're looking at coming back here, so this is what my integral is always going to come up with, is from there to there. So when I'm calculating out my height, I want what's in here. I want this piece right here. So I need to take the 1 all the way back to the axis. So my height is going to be 1 minus, and I'm subtracting off that y squared part, this piece over here, which I don't want. Okay? So my height is now 1 minus y squared, not just y squared. If it was y squared, I would have found this area in here instead of that area.
The 1 minus y squared just brings the vertical line that we had. Actually, the one back to the y-axis.
Basically, yes.
So if that was 7, it'd be 7 minus y squared.
If we were looking at it from 0 to 7,
Yeah.
yes. Well,
Okay.
it wouldn't have been 0 to 7, but yeah, I know what you mean by it.
Okay.
Okay. Does that part make sense or no?
Zero to anything.
Yeah, because you're looking. It depends on what section you're looking for. So they're looking for, because we're rotating this axis around the x-axis. So we're looking for this piece in here. Okay. If I was looking for this piece out here, it would have just been y squared, because that's that part there. But since I'm looking for this piece in here, I would basically make this a rectangle. That's what 1 is. And I'm subtracting off that part there. Okay. And that part there is my y squared. That's the drifter. Okay. So now I set up my integral. 0 to 1. It's 1 minus y squared. Because we're taking this rectangle here. That's the 1. And we're subtracting off that piece, which is the y squared. So 2 pi y and 1 minus y squared dy. Yes.
Our previous example,
This one?
was rotated about
The y-axis.
y-axis.
Yep.
But we put it in terms of
X. Yeah, so if it's rotating around the y-axis, it's going to be y equals for the cylinder method.
Oh.
It's opposite of the disk method. So if we're rotating around the y-axis, we want y equals. This one is rotated around the x-axis, so I want x equals.
no, okay,
Yes? No?
yes.
But
Trying to figure out why the different methods need the different in terms of
because you're looking at something different. So for this one, when I was looking at rotating the disc was going from here to here.
in this current example.
Yeah, actually, this problem we've done. We did this problem last Thursday using the disc method. The exact same problem. And actually, I was going to put that up there in a minute. So if I was looking at the disc method, I'm looking at from here to here. So my function is this. That's that x equals or y equals x or square root of x. So I can use that. Since I'm now looking at going this direction with the piece that I'm rotating. That's why that now has to be in terms of the y, because it's now a y function, not an x function. The answers.
In last class's example with the same y equals
Yep.
square root of x, were we rotating about? We were rotating about the y-axis
This one right here.
in that example.
We're rotating around the x-axis. This is the exact same problem. Yes.
Oh my God, I did it.
Yeah. So the answer is exactly the same.
I think the mistake of putting in the wrong numbers.
Yeah. That's what you should have gotten for this answer. That's the answer for this one. Oh, sorry. I didn't switch back over, but that's okay. Yes. That's what you should have gotten for this problem, but I'll go back to the other one.
So this is where my brain goes. I do a lot of unnecessary things. Just like this, my algebra. But like, when it comes to the same answer,
You just try it.
you skip steps, so I have to like remember those steps.
If I skip a step and you don't remember that step, tell me, I'll put it in.
I'm really lame for everyone.
No, it's not. Trust me, they're all missing steps too. If it's such an, if
I
it's
actually did it for the
awesome, you're getting there.
first.
It's like if it's one of those steps, like it's like I'll just tell you, I'm like, just do that. But like sometimes I'll skip a step that, yeah, sometimes I'll skip a step, and if you don't understand how to get there, that's why I don't typically just copy the answers from the book unless I've gone through them, because a lot of times the book will skip a bunch of steps, and then you get lost. That's why when I wrote my explanation, having my writers write the explanations, I tell them write everything out because it's always the little things that students get skipped. Yes, that's okay.
Sorry, I don't know if I fully understand.
Okay.
Understood what.
All right. So this is the same problem.
Yep.
We're rotating around the x-axis. Okay. So my radius, which is the piece in essence that I'm looking at,
Your radius is changing.
my radius in this one
Yes.
is the square root of x. Because I'm going from the x-axis up to that function. That's my radius.
Oh, so in,
Okay? That's my radius. My radius is in essence, if you look at this, and then you look at this, the radius is the same. Right?
sorry, this one is also about, no, this one's about.
This one's about the x-axis. It's the exact same problem. We're still going around the x-axis. This is my radius right here. Right?
What substitutes it for height?
I'll explain that one in a second. You don't have a height for the other one because you're doing discs. You're looking for the area of the disc. So you didn't need height. Okay. So look at this problem right here. This. And look at this one. My radius is the same.
Yeah, no, I have to do that.
Okay. In this one, I'm using my radius as y. And this one, I'm using my radius as y, but it's the square root of x because y equals the square root of x. They're exactly the same thing. My radius did not change. Okay. The piece that changed was when I was doing the disk method, I don't need height because I'm looking at the area of that disk and I can find area with just radius. Okay. No, area volume is a collection of a whole bunch of areas.
How did we find the volume? We,
Because we're looking at adding up all the areas of those disks. That's what this equation is doing. Is it's finding the area of that disk and using the integral to say, okay, I got the area of this, all those disks. Okay? And since for area of a disk, I only need the radius. I only need that one piece of information. So I could do it in terms of the square root of x. This method, which is harder for this problem. That's why I wanted to show you the two of them. Your radius is still the same. We're rotating around this. We need this height. We're rotating around that cylinder. And that's the area that I'm looking for. I'm now looking for the area that basically the surface area of that cylinder, which is radius times the circumference times the height. This height is here. Okay. That is now what the answer that I would get when I plug in a specific y value. And that's why I need it in terms of y. So I need x equals. Because that length is going to be telling me the length in x when I plug in a specific y value. Okay.
How is always going to be the function?
I know that I can figure out that for this one we set up the equation this way, and for this other one set up the other. Yeah, I can do that, right? I can.
In essence,
Yeah,
that's
but,
what.
I don't know what the fuck I'm doing, right? I'm just plugging numbers in and
Okay.
doing the right thing. So
All right.
I'll talk to you later.
I got what you're saying. Yeah, that's fine. I'll be able to explain. I know exactly what you're saying. All right. So for his little piece, for those who, because in all honesty, write this down. I was going to put this at the end, but it's perfect now. So your disk method, if you're rotating around the x-axis, it's got to be in the form of y equals. If you're rotating around the y-axis, it's got to be in the form of x equals. The shell method is completely opposite of that. If you're rotating around the x-axis, you need it as x equals. If you need a y-axis, you have y equals. It's designed that way because these are two methods to solve same problems based on which one is easier to do. Okay, so I will tell you right now, the way that the test is going to be written, you're going to have probably 3 questions. That'll be volume questions, and none of them are going to tell you which method to use. You're going to have to figure out, okay, this is the easier way to do this problem. I'm going to do it this way. The answers will be the same. But you can use whichever method you find easier to do for that problem. And some of them you could do both. There'll probably be at least one that you're going to have to do one way and then one the other way. But probably around there, yeah. Might be a few more, but I normally shoot for 10. So, all right. Okay. I commend you. Nobody took out their phone and took a picture of it.
I did too.
Oh boy.
So I don't actually have a problem if you did that. I will tell you, you don't remember it nearly as much.
Well, I was gonna do that and then write it down here.
So, as I told my students when I was at high school, because they would always just take a picture of the screen, you're never going to remember it, and odds are you're probably never going to look back at the picture anyway. But the act of physically writing something helps you remember because it's the rule of 3. To write something, you have to read it off the board. You then have to physically write it. So that's the second time you're interacting with that information. And then you typically read it off your paper to make sure you wrote it right. So you've now interacted with that information 3 times. If you ever do something 3 times, you're probably going to remember it better. By just taking a picture of it, you didn't interact with it at all. So every time you try to remember it, you're going to have to go back and look at the picture. So that's, and so sometimes as teachers, we think you write things. That's why that physical act helps you remember. All right, let's go back and do a few more problems. All right, so we've got this one.
Rotating about the y-axis.
We're rotating about the y.
Y equal.
So we have y equals x and y equals x squared, and we're rotating around the y-axis. I'm going to make your life a little bit easier because I don't feel like having to go through and look at it. You're looking at it in terms of from it's 1. Actually, it's the x value. It's from 0 to 1. Because these intersect. That's at 1, 1 and 0, 0. That's where they intersect.
So our height here is the area between the two.
Yes.
So in our washer method, it would have just been.
The radius would have been the difference.
Okay.
The radius would have been that subtraction. In this
which we
case,
would
it's the
have
height.
Just found in the into.
Yes.
Now it's on.
Yes.
Okay.
All right. So, yes. Oh, you're distraction. All right. We need 2 pieces of information. We need my radius and we need my height. We're rotating around the y-axis. So my radius is that, which would be x. It's how far I've moved away from the y-axis, which is my x. Okay? Yes. Yes, that's my height right there. I'm going to explain to you why. So in this case, remember, whenever we're looking at things, it's always going down to the axis. Okay? So when we're looking at this, it's going, the height is going all the way down to the x-axis. So my top function is x. And I'm subtracting off my bottom function, which is the x squared. So that's the height of that shell or that cylinder. Okay? It is still top minus bottom. And if I were rotating on the x-axis, it'd still be left and right. That's still true. Okay? Any questions with how I came up with those?
rotated about the axis, wouldn't it be right minus left?
Oh, I said left minus right.
I don't think you said left minus right, you
Okay.
said left and right.
Yeah, it would be the right minus the left. Yes. All right, so my integral, we're going from 0 to 1. It's 2 pi times my radius, which is x, times my height. All right, find my radius, or find my integral, or my. Yeah, do the math. I can't speak tonight.
The thing we need to write down. No. Let's see if there's-
Just wait. If you remember your Calc 1 class, Calc 1 was nice in the beginning too.
No, it wasn't. I hate this.
Oh,
Oh, yeah.
this is why I don't do those. Like I won't cover, like I won't do the Riemann sums and stuff like that, because it's like, it's just, I would show it to you and then next thing I'd show you would tell you don't have to do that. So there's just no
Never
point in
do
me
it
wasting
again.
my time. Yeah.
All right.
So there's no point in me wasting my time. But you do have to do it at the beginning of Calc 1, because if not, you really have no understanding of what the derivative
Yeah.
really means.
I just didn't like different squishes. So I did it once and never again.
Right. You're going to do that once and never again. And it's like, yeah, that's,
Especially 'cause I did it in the pre-calc. And I did it again, that's really calculating.
all right. So you should have gotten that. Whoa. You should get. Yes.
No. Yeah.
All right, we're going to do this problem next.
So I'm
Actually.
looking back his hips. I just like. every hip.
All right. So that's what we got. All right. Let's look at this one next.
Like day 2 of the thing that's easy like the first month. Or like the one semester I don't really.
Well, Thursday it's going to start getting tough.
First week, 2 weeks. Wait.
Yeah.
I drop periods done and now here's the really hard stuff.
All right. So this one, we're looking at the solid rotated around y equals x minus x squared and y equals 0 around the x equals 2 axis. So is it being rotated around the y-axis or the x-axis in essence? Right, because x equals 2 is vertical, so it's going against the y-axis. Okay, so we're going to look at this in terms of just like the y-axis.
Missed the entire problem. Okay.
Here's a nice little picture of the problem. There's the problem. So this is, no. So this is my area. That's the area that I'm rotating. Okay. So I'm rotating from 0 to 1. We're just rotating around x equals 2.
We would have to add
So let's go back to the same concept that we've been doing. We need two pieces of information, correct? I need my radius and I need my height. So basically the y because it's vertical. So my radius is what?
X. Minus X squared.
Minus X.
Minus 2.
All right. So
Wait, would it be
my radius is from here all the way to here, right?
2 minus X?
So I think we've now said every possible one.
Hey, guess and check.
So that's 2, correct?
Yeah.
Good. And this is whatever my x is that I'm looking at, right?
Yeah.
So that's my x. So my radius is going to be 2 minus x. Because it's 2 minus whatever that's going to be.
So we're just taking our part of the graph and calling it X and calling it.
Well, because this is, say we're right there. Say we're looking for that cylinder.
Yeah.
The radius is from 2 to what minus a half. Because that's where I am in the x.
Not one, it's anywhere in between.
Right. It's anywhere in between those two things. So that's my x can be anywhere between 0 and 1. My radius is going to be 2 minus whatever that happens to be. That's why it's 2 minus x. Yes.
The drawing.
Yep.
That blue.
That's just one cylinder. That's an example of what the cylinder is. It's not the whole shape.
It's the whole thing's a donut.
Yeah.
It's a fat donut.
Yes. Yes. Yeah. It's a donut with a big hole in the middle. Yeah, more of an onion ring. I'll do that. Yeah.
It's a scale.
So why don't we care about the other side, or is it just?
What other side?
Show us that-
Well, if you're rotating it around that axis, you get both either way.
Right.
No, it's more of a donut because it's an inch thick, like the actual, and then the hole's like 2 inches.
Right.
So like, what onion ring is like?
I guess it's
It's a really fat onion.
there's a really fat onion,
It's more-
but it's also a really big open donut.
it's a thin-
Yeah, donuts normally like an inch and they're like an inch on either side. So it's like if this was like at like 1.5, then it'd probably be. All right, now that we're all getting hungry, the Dunkin' Donuts guy was trying to give me jelly donuts, and I got there, and then now we're talking about donuts. So it's all good
Yes.
because I didn't want jelly donuts.
Are they free?
So all right, so everybody understand where the 2 minus x comes from now?
Yeah.
Good.
Minus
Yes.
donut.
The donut minus the hole. All right. So now, what's the height? The height goes up, right? I'm just doing it over there. It doesn't really. So that's just the x minus x squared, because that's going to give me that.
So our height is going to be our function.
Typically your function, yes. Unlike we can have situations like we did in this one where the height's a difference of functions. Yes,
Scare me.
we did this one. It's the same equation.
Oh,
It's the same function.
that's the same answer.
No,
Oh, that's great.
because it's first of all, it's rotated around a different thing, and my radius is different. Similar question, not the same question.
Oh,
Actually, the answer does not go out.
sorry, I put this X instead of 2 minus X.
That's okay. Then yes, for you, that would have been the exact same question. Yes. No. Set up your integral. Yes, we're doing math. Set up your integral. Because this time I didn't set up the integral, so I want you guys to set that part up. I can check yours. And try it. If you get it wrong, you get it wrong. Try it. Yeah, 0 to 1. But if you write it and it's wrong, I can fix your mistake rather than just telling you again, which isn't helping very much.
You're right. It's not. I did spend all weekend doing calculus one on comp.
Awesome.
That was just,
How the derivatives. Very good.
It was horrible, but I needed to do it. It's been 5 years.
Whoa.
Yeah. I asked less stupid questions.
We have the same thing, it's just in a different order. Yes.
It is.
I just put mine in
Oh, you're
standard
right.
form. It made my life easier.
I didn't want to go through all that. It's like,
Yes, that's why. Don't forget your DX.
what is it?
Don't forget your DX at the end.
Sorry, I don't know why we're
You do because
like, I kind of do, but like, I don't actually.
because it's the antiderivative. It's basically it's the canceling of that piece out.
Huh?
In this
It's
situation,
the same thing.
integral. Yeah, yes, that's why because so the DX stands for the derivative of X.
That makes sense.
Oh, I thought it was 2x. Or
Okay, yeah. One thing that you don't want to do by accident is don't forget the parentheses there because that will sometimes
It'll
screw your.
I can do what you get.
Right, you did deploy.
I'm not doing that well, so
Sometimes
tonight.
not putting parentheses there will make you think you don't
Oh my-
have to do your foiling. It's those little things that as we get more complicated
That bad.
Yeah, I don't.
can come back and bite you afterwards. So
I like that good for a second.
yeah, you did fine. All right, so that's what you should.
Oh, that's what I
Oh my
got.
God, I
Yeah,
don't want
so-
to keep-
Yeah.
Don't look.
Okay. Okay. You're saving me.
Yeah, that's
Thank
what I
you.
got. Say.
I'm like not even sure if I can foil.
How?
Well, when you foil, you can look. I took the part.
Yeah.
The only thing that's there is the foil piece.
Yes. Yes.
Yeah, it was just.
Yes.
You had me doubting myself. Can't believe you. Did you foil out and then simplify?
Yeah.
Minus 3 plus 2x. It's minus 3x squared because negative 2x squared and minus x squared combined to minus 3x.
I'm also not doing that right.
I was like, I didn't make a mistake this time.
No. It's not.
You got foil.
No, I forgot to-
Obviously.
forgot to do that.
Oh,
I did something.
Hey,
all right.
it says.
I couldn't do
Well,
it. Algebra.
yeah,
That's the majority of the mistakes people make, believe it or not. So
Well,
I was gonna get that number sticky,
So I needed to do.
but I didn't want to do that. On that.
I think you forgot your fraction.
do the practice thing.
Yeah, you forgot your fraction. All right, so that's what we got. All right, so now we would go to the slide of what I was just going to show you before, which is this method, which is this, which you already wrote down. So we're good there. All right, so I want to find.
You can't look over at me like I can.
I want to find this one. So the way the equation is set up, which method should you use? Or which method is it kind of leaning towards?
I would like to do this.
This is looking at the shell method because it's in terms of y equals. And it's around the y-axis. Okay. So this is that shell. If you wanted to do the disk method, you'd have to solve each of these. So you'd have x equals
So we
y
just
over
take
2
because it's just
and x equals the square root of y. You'd have to switch those two to do it as the disk method. So it's really which one's easier for you to work with. Okay. And that's really what it comes down to. Like, so this one, honestly, this method's probably going to be easier for this. The equations are 2x and x squared, probably going to be easier to work with than a fraction and a square root. Okay. But it doesn't matter. Okay. And that's really where sometimes you're going to have to make the decision on which one you find easier to work with in that case. If you're really good at the disk method and you can switch into the disk method, do the disk method. That's fine. Okay. Like I said, I'm not going to have a question on the test that says you must use disk method, you must use the shell method. I'm going to give you 3 problems. I will have a couple of those problems that will lean towards a specific way that I think you should do it. But if you do it the other way and it comes out the right answer, you're good. All right. The answer to the last one was pi over 2. All right. So right after class, let me see. I'll look at you. Thanks. Yes. Oh,
no.
sorry. Yeah. All right. So I've got this set up basically so you can do either method you want. The one thing you do need in either one of these, in either method you're going to use, your radius is 1 plus this side. That's how you do that. Because remember, we're always going back to the y-axis in this case. So that side's the 1, and then you have this side over there. So it's going to be 1 plus whatever that is. Well, it depends on what method you're using.
For disk method, or sorry, shell method.
Shell method, it'd be 1 plus x.
Plus x.
Yeah.
Or just x.
Because my x is what's changing. So if I'm here for my shell,
Oh, I
it'd
see.
be 1. So it wouldn't matter.
And then 2 times
And I think this is going from 0 to 4.
our r.
So that's 2, 4, 0, 0, and 2, 4. And that would also change depending on what method you're going to use.
Wait.
I am going to give you the answers for both of them so you'll see both the work for both of them done. Yeah,
Would it be 2x minus x squared or x squared minus 2x?
2x minus x squared. It's
For shell. For shell.
for shell.
Yeah.
2x minus x squared. Because the height's going down. And the 2x is on top.
Okay, thank you. I was thinking disk method.
If you're doing the disk method, your radius would be square root of y plus 1 minus 1/2 y plus 1.
Negative 2.
No. Positive 2.
Is 0 to 4, right? 0 to 4, not 0 to 1. It's going up to 4. I'm doing with respect to line items.
Yes, we.
This is from 0 to 2.
Oh, you messed up your. Third.
That was just against the notes. I'm looking at like
Indeed.
everything you did after that. Except the.
Which of the third is 64?
Yes, go to the fourth.
256.
Yes. Overhand was always multiples of 64.
Fine. Oh,
These two bring that up.
I mean, it makes sense, honestly.
It doesn't matter because you used to do that before anyway, so we didn't need to do it.
64.
Yes.
Oh, so it feels real.
Yeah.
To me. You lied to me.
Wait. I copied the right one. Yes, I did.
2 squared. Why is it called?
So that's the shell
Why is it 0 to 2?
Why is it 0 to 2?
because the x is 0 to 2.
Oh. Because I didn't put the y. That's why.
Over 3. Which of those ones is 16?
So the easiest way to think about that is remember, these over here, your interval has to relate to the variable that you're looking at. So since these are x's, it's going to be your x points in this one, which is the 0 to 2. If they were the y's, it'd have been 0 to 4.
Yeah, like my number's kind of big.
Yeah.
If you're doing the disk method, which I don't think anybody in here did, from when I was going around and looking, this is disk. Notice the answer comes out to be exactly the same.
Yeah, it just looks like it's gonna kill you.
So, well, this one, you have to do those two foils. It's like, that's the thing. It's like when you're looking at the problem, you have to look at which way's easier for you. Like, I could have given you this problem and shown it to you with the x equals square root of y and x equals y over 2. I could have given the equation like that, and you would have instantly like, oh, I got to do the disk method and just gone with it. That's the part that you have to start looking at, is when you're looking at the problem, figure out what method's going to be easier for you to do it. So in this case, if I gave it to you that way, you switched it, it would have been easier to work with. Yes.
Not sure how you got, x plus 1 and
Okay, so the x plus 1 comes from here.
yeah, well, why did x plus y squared? Because that's the further out. That'd be
Okay, so your radius, so remember, we're plugging in essence, we're plugging in x values, right? Okay, so if I put in x squared, that's a y value, because y equals that. What I want is, if I'm coming to this point right here, it's, say that's 1.8.
Okay, I get it.
Okay, how's the same radius be 2.8? Like normally it's that one little thing. It's like then it clicks. Yes,
Another question.
sure.
So is the height, I don't understand why the height is,
2x minus x squared.
isn't that, that's,
Your height is this piece here. But remember, it's in essence that minus, hold on a second, we're gonna do it this way. That minus that, which is why it's 2x minus x squared. And then if you looked at the disk method, that would be your rightmost equation, and that's your leftmost equation. So it's right minus left. And it's just a bunch of FOIL. So again, both work, both come up with the exact same answer. Both can be done. You just have to decide which one you want to work with. I'm kind of glad I did this in 2 lessons instead of 1. It all depends on the class. Sometimes I can go a little quicker, sometimes I can go a little slower. Doesn't make much difference to me in the end. You guys are about in the middle at the moment, so. All right.
Can't do it.
This is right before, right? Yeah. All right.
This is just not right. Why you going about it?
Okay, so right. As it's labeled right there, as it's written, it's y equals around the x-axis. So my first inclination would be to do the disk method.
This is too high.
sorry, we're on another problem.
Oh yeah, I can go back to the other one if you want, if you need it. You only had to do one method. I just showed you both. Are you writing down the other one?
I'm not ready, I'm doing the.
Oh, you're working.
integration right now,
Oh, okay.
so I should be getting it.
Okay. So yeah. So work on your integration, and they can work on this one. It's fine. I can check your next.
Zero.
Sorry for
squared is just 0, right?
Yeah.
I went back. Sorry. You did.
Yeah, I just need to do them.
Okay. Yeah, so let's just. Square left.
What do you need? 10 minutes?
30.
Yeah, you get 30. 30, we're going home.
That's the
All right, I'll give you 10 minutes. I'll give you the 7:50, but I think it's like 9 minutes or 6:50. So.
Yeah.
That's how I set it up.
At any point, if you're stuck, or you need help, let me know.
So I wrote the problem.
Okay.
That's all I got.
Right.
This is power school? Okay, well, same difference. Wait, I'm not into those.
You're looking at it in terms of you didn't access. So,
And then it's just asking, yeah.
Wait, is there an extra? No. This is pi.
This is power square.
Wait for 4.
Yeah.
Or 2.
No. Yes.
If you grab the middle floor across
As it says right there, you factor it out. You have to factor it out. If I do it. If you're gonna do it out there.
the 16 plus 30 Celsius. Yeah. Do you get like the nasty? You know what? 48. 6 times 8, I used to hate, but now I know it's 48. All right. What's wrong with that? You guys actually do that whole thing. I did. That's what I'm saying. Trash problem.
Is Aiden here? That's you. Okay. I thought it was you, but I wasn't positive.
Who am I?
I don't know. I seriously, I am even when I was in high school and I had the same kids all year, and I had I was horrific with names. The only time I ever remembered people's names was I gave them a nickname. Like that's the only time I remember.
Okay, so now we have.
Okay, so you're also in that. Oscar.
Wait.
The practice.
16 plus is indeed 52. Thank you.
Practice is just for you to practice.
16 plus
So, you're all set. 5 more minutes.
It's just here. You get this when you boil it out.
Thank you. I'm not,
That's the hardest part about this.
Oh, you're doing it.
I was working on it.
The boiling just
Something
sucks
down.
for this one.
I was,
It's a final.
I was going to,
I don't know what I was doing over
but I wasn't gonna do it. Maybe
Okay, so you are trying the Cal method because you're ready. But
Where do you get minus 96?
The 52 divisible by 3.
So I need to
So why?
Yeah, 1 second.
Oh, I'm gonna do a calculator.
So you don't need to hide. You just read.
So, no, sorry, I forgot. There's a minus 96x. DX. 52 divided by 3.
Yeah, but I had another number. I was supposed to know it's something.
That's right. Because that's. So, no, so you're, remember, you're just doing for investment, right?
Yeah.
So the ratings are going
I'm
to.
actually gonna put 40.
No, what? There's no-
Save that.
The equation.
Can you plug it in?
Okay,
So that's, that gives you whatever that height is.
okay. So it's literally just.
Is that,
So,
and this one's actually pretty straightforward, it's just that. There's no minus or anything else in there. But remember, the formula for area is not 2 pi. Formula for area is pi r squared.
Usually pi r squared.
That's the formula for area, yeah. So if you're doing the disk method, you're using pi r squared. If you're using this shell method, it's 2 pi r. This one you're not doing it.
the hardest part's plugging it all in.
So,
Yeah.
Can't you just put in the formula and then separately do FT?
I think there's a meeting that we do this, but I'm not doing this.
Which means if you rotate it around the y-axis, I think.
Wait, theoretically, if I just square my final answer, will I get the same answer? Theoretically.
No. Because remember, you have to FOIL out what's inside the square, so that doesn't necessarily going to work. So there's my picture. Don't worry, I'm not putting the whole answer up there. For those that are still working.
Uh-oh, what did I do?
What did you do?
No, I did nothing.
I was like, where did your fire swear to?
That's the R. It's okay. Those are things that as you work on and practice them, you'll start to it's like, okay, that's the R, that's the this, that's the that.
Aha.
You do it all.
Fraction. 5/12.
All right, so you should have the integral from 2 to 4 of pi negative x squared plus 6x minus 8 squared. This is just your function is your radius. Remember, my radius is that part right there. And that's going from the x-axis to my function. And there's only one function here, so I don't have to do any subtraction or anything else in that respect. Usually foiling that 16 pi over 15. Yes. So there's 3 terms in here. Foiling it out is messy.
I feel like there was a trick to foiling trinomials. And I can't remember what.
No,
Just
there was a trick to doing powers of a binomial, and that's the Pascal's triangle. I've been doing this for 25 years. Most of this stuff I still don't do in my head. Purely because it's really easy to mess up a sign when you do things like that in your head. So you should have gotten x to the 4th minus 12x squared plus 52x squared minus 96x plus 64. If that's not right, everything else afterwards is going to be wrong because you're going to do your integral wrong. So this is why I said the number one mistake in this class is not the integration, not the calculus, it's the algebra. And you're even going to see that when we move into chapter 7, when I teach you new methods of integration. The stuff that's going to screw you up is the algebra stuff of how to simplify things down, not necessarily the actual integral rules. So this one you cannot just plug in the 4 and forget the 2 because they're not 0. So you do have to do both. How did I get the square of this? It's foiling, it's just with 3. So you have to do negative x squared times negative x squared times 6x, negative x squared times negative 8, and then do 6x times 6x, that times 6x times 6x, 6x times negative 8, and there's 9 of them that foil that into that.
That was I didn't do. I had the calculator do 5/12 minus 496.
No, I'm not doing that either. That's what your calculator's for. If you've got the actual foiling done correctly, the integral actually, I believe most people in here can do. So from everything I've seen walking around, this step here from here to here is not the problem. So great, you know your calculus. That's not the problem. Every problem that I've seen so far has come from algebra mistakes, or just mixing up how to set up the problem. So, which that's to be expected in this situation.
I'm just happy I was able to play that out.
So
That's my accomplishment.
I want to do
Algebra one class and be like,
58.
there's two variables, can't do it.
Let's do 58.
So I'm just going, "Hey, the zero." We're gonna factor it. Yeah, I mean,
Oh, yeah.
I took the credit. Katie, I should have Katie on that. Katie on that.
All right. Any yes.
So for this problem, there just so happens to be just the one area.
Yep.
Minus nothing.
Yes.
Can you it's just because it's being rotated about the x-axis and one of the bounds is the x-axis.
All right.
So if it were y equals -1, we would have to.
You would have found a different 2 and 4. So
Trying to,
okay.
in previous examples, last class, we did like an outside area and an inside
Yes.
area.
So, like, actually, I can go back to this. This one's a perfect example of that. If we were looking at this in terms of the disk method, okay. If we're looking at this one in terms of the disk method, I would have this area or this area out here, the x equals y squared minus the y over 2. And if you look at the integral setup, see how it has the square root of y plus 1 minus the 1/2 y plus 1. So that's that right minus the left. So in this problem, I only had 1, so I didn't have to do the right minus the left. If it was shifted up, so say I was rotating it around y equals 1, then I would have done 1 minus whatever, or yeah, I would have done 1 minus the area of that equation because it would have been shaded up there. The reason why you need to have the y equals 0 here is because I need it cut off here. Because if it's not, there's an area over here that still could be rotated. So by saying the y equals 0, I'm cutting it there. I'm not worrying about this piece down here. That's why they have to tell you that piece. Right. Yeah, that's why they have to tell you that piece. All right. Let's do this one.
Can't do it. Impossible. That's also the disk, right?
I didn't say anything about it.
Okay.
I just said, there's the problem.
It's shell. They're rotating about an x-axis.
You're going around the Y.
Y equals 1 is a horizontal line.
No, it's not. Yes.
I was waiting for the light bulb to click.
No, I knew.
You just wanted to argue the point. It's like sometimes, sometimes just waiting for the light switch to click on.
Okay.
Oh, yeah, that's right.
This is 2 pi r h. L. This is shell. Yes.
Yeah.
It's gonna be 1.
And as in a semblance of time, I'm going to give you the picture.
Thank you.
Here's the picture.
That's what I wanted to see.
I forgot to put the X Why is there nothing on?
Yeah, for y equals you don't have to, but for x equals you do. You could do either. I'm not telling you which one you could do, which one you have to do in this case. Yeah.
Well, it's an x equals and we're going on the x, right?
Hold on, because I was looking at something else. What was your question? What was your statement?
It's an x equals.
For your radius or height?
On that y equals one.
Yeah. Hold on 1 second. Reverse. What was your question?
So it's an x equals and we're going around the x.
Yes.
So we should use, yeah.
Yes. Unless you want to solve it and go the other direction.
Or h is y minus. Because we have to measure the y-axis.
Yes, you have to go to the y-axis. Exactly what you.
Okay, that's what I was.
Yes.
Oh, what's one max? I don't.
I'm not laughing at you, I promise.
1 minus 4.
Minus X.
It should go from 1, no. Need to go from 0 to 4.
So but you're probably at, yes.
No.
No, it's 1 to 5.
Yes.
It's not 0 to 4.
No.
Wow.
You're looking at your
Oh, because it's the Y and
you're looking at your y's.
the.
Yeah, okay, so it's 1 to the bottom.
Yes.
1 minus.
That's supposed to be a Y.
Yeah, probably.
All right. So
1 minus y. I have so much fear of that.
There's it. Oh, there's the Y.
I'm sorry, I got backwards. I was just, I wrote that and I'm like, that does not look right. That's better.
Why is it minus 1?
Because we're rotating around the y equals 1 axis.
Minus 1.
Same difference.
1 minus y is not the same as y minus 1.
It's minus.
So
we
it's
have
the
to go down one.
foil.
It might be.
It doesn't change my math so far, so.
Yes.
For radius, I got 1 plus y.
So remember, we're always going down to the axis, right?
Yeah.
So since this is above the axis, it's subtracted. Because I have to go through that point to get to the axis. So I'm taking that part off. If it was down here,
If it were rotated about the x-axis, it'd be 1 y.
if it was rotated around the x-axis, it'd be just y. So if it was rotated around the x-axis
Yeah.
and not the y equals 1 axis, first of all, it would go down a little bit further, but that's not the point that we're looking at. It would have been whatever y is at that point. Because I'm not looking at, there's no point I'm cutting off. And this one, since I'm cutting a piece off down here, we're erasing out. Since I'm cutting this part off, that has to come out of the y. So in this case, my y, at the end, my y is 5. Right? At that point, my y is 5. But the actual length that I'm looking at here is only 4 because it's 5 minus the 1. So that's why it's y minus 1. And then the height is the same concept. We're going back to the y-axis. So we're looking at that rectangle of 4. So that's that 4 minus this chunk over here, which I don't want, which is this.
Why do we have to bring it back to the y-axis?
Because that's the direction your height's going. And it's always going to go the way the integration works, it's always going to go back all the way over. Because it's looking for area of that whole thing. If you didn't do the 4 minus, you'd have gotten the red section. When I want the section in here.
So we have to boil it on, is that what we do?
Yeah, there's some flooding on this one. You have to FOIL the y minus 3 squared, and then you have to FOIL the y minus 1.
Can you distribute the negative first and then just foil it?
that's not square though.
No.
You have to foil it and set up the y.
Yeah, so here, I'm going to show you this too. So this is the foiling steps. So it's from 1 to 5 because that's y. 4 is right there. So they foiled this and then they did 4 minus that. So when you FOIL this, you get positive 9, so minus 9. So 4 minus 9 is negative 5. And then you have to FOIL that. Which
So
gives you
no
this.
matter what. Why didn't we go back to the, we did go back to the y-axis and all the other ones?
Yes.
It was just red, like different.
Yes. We always went back to the y-axis. And we always went down to the x-axis. Because integration is finding area under a curve. So when you're looking at integration, it's always finding it to whatever axis we're looking at.
It's just, I know why it's confusing,
So
because it's down method. And we're doing that on the y-axis from 1 to 5.
Yeah.
And so. I'll bring Well,
remember, you were having so much fun.
I am having fun.
Yes.
I'm just tired.
So, if it were, the previous example, we're going from that point to that point. That's like, that's what that is.
Yep.
So I'm doing, and like, the left number goes on the bottom of
Yep.
it.
Yep.
So, but if I'm going this way, is it still the left number goes at the bottom of the integration?
No, it's bottom to
Okay, so the right number goes at the bottom.
the way you have it written, yes. The way you have it drawn, yes.
Well, I mean, that's how it is.
Right, but it's always the biggest.
Yeah.
It's the biggest is on top, the smallest on bottom. Same concept here. Biggest is on top, smallest is on bottom.
Okay.
It's not necessarily right, left.
Sorry, the easiest way for you to figure out the like f of y stuff is to just look at it this way and just try to apply the rules of x.
So.
Yeah.
We're rotating, so look at it this way. Because that's really the axis.
Okay.
That's the intersection line.
Can't wait till we get to our trig rules and trig functions and plugging all those in. This is, like, shit.
So. Like, combination, like. Something, I don't even know.
What do you mean when you put all this in?
I'm gonna try and integrate.
Okay, you must have put your sign somewhere. Oh, you must have put your sign here.
Where?
Here. So you're foiling.
Oh, I did some side coils.
That's okay. So this is right. Okay, but it's 4 minus that. Which gives you,
I forgot that was there.
right. Which is.
It's like it makes everything garbage.
Yep. So side foiling is fine. Just don't lose things. As long as you don't lose things.
Hardest parts of the literally coordinated.
I don't even know where to put that.
That's going to be, then you have to multiply that by the y minus 1. So this piece right here is the piece that was wrong. So it ends up being negative y squared plus 6y. You had y squared minus 6y. Those will change because of the minus sign.
9 minus
And then it's
4
4, yeah, 4 minus 9.
Last problem.
So. All right, let's see. I just need the last part.
Well, that changes things.
So. And there's the integration part and then the final answer.
Okay, you're saying.
There you go. That cleans up that nicely.
Unless you're, so these are things that I've learned now writing a book. So when you're making up, like if I try to make up a problem, these are very hard to make up that work out really nicely. So a lot of times they'll come up with like, okay, this is what they wanted it to look like at the end, and they work completely backwards to find the problem that makes that work. That's why they work out pretty nicely most of the time.
How would you work it back?
You'd come up with like this. This is what I want my integral to be. So like you have a general idea of what this is, but I have like you would then start manipulating things to get the equation to work out the way you want it to. And then you stick it in the book. Yeah.
You know, this class went by really fast.
Yes. Good say.
I was prepared to actually.
Yes.
I can have it out.
Yes, you can. All right. Stop recording here.